Hello everyone, in this episode we will try to understand how the JavaScript array method reduce works. We will recreate our own version along the way like we have been doing. First, let's create our file and call it reduce.js. We will of course have our own array for demonstration. Let's call it nums. 1, 2, 3, 4 and 5. Great. I think it makes much more sense to look at the reduce method in terms of what problem is trying to solve. Imagine you have an array and you want to reduce it into a single value. A single value can be a single number, a string, an object, or even another array. And that's exactly what the reduce method is for. Let's demonstrate with a basic example of summing up all the elements in an array, or in other words, reducing the elements into their sum, which is a single value. Okay, so we have nums dot reduce. Okay, takes in second argument here 0. So I will explain what I'm doing in a moment. Text return as item. We say sum not reduce see. We have the 15 here. Let's see what's going on. We are calling the reduce, right? We are calling the reduce method on this array. It expects, that is the reduce, it expects a callback, this one here. The callback is going to be called for each and every element, taking in, right, for each and every element, like so, taking in an accumulator, taking in the accumulated value at the current elements 10. Let's say we are here, it takes the accumulated value here. We are here, it takes the accumulated value here. We are here, it takes the accumulated value here, and then it also takes the current element and its index. The second argument, this one, is the initial accumulated value. So this is the initiation of the accumulated value. So when we are starting here, okay, the accumulated value is going to be called when we are at this element 1 here, will be 0. So if this is left out, the initial value will be the first element of the array. Okay, if this is left out, this here will be the initial value. Okay, that would also mean we'd have to sort of jump this element and maybe start iterating from here, with the accumulator being the first value. Because then if we take it as the accumulator and the first value, it means that we are going to work with it twice. Once when it was the accumulator, and the second time when it was is 10 when we call the callback function. So the callback function should return the next accumulated value. So what is returned here is the next accumulated value, which we will have either at the next call. Let's say it returned this, right? We'll have it when we are here, right? When we are calling the callback to the accumulator that was returned when we were calling it with 1 is the one that comes in here, or at the final call, in which case it would be the overall value returned by the reduce method. Okay, so if it is the final call here, right, we are calling this with 5, the item being 5, and the accumulator being what we got from here. Okay, then what we are going to return is another accumulator, but then we don't have another we don't have 6, for example. After 5 we don't have another number after, so it will return it, and that is what is going to be gathered by sum here. Now let's build our own array dot prototype dot, I'm going to call it reduce with s. It's got a function. The function is expected to take in another func and an init, okay, for initialization, for initializing the accumulated value. Now let's have the array, the one we are going to call our reduce on, say it's nums here. As you have seen before, it's in the this, so we can say const is got this. Now there are variables we need to create also here. We need to create let's use let the result variable, and also the I variable. You will see why in a moment. And then we check if init is equal to undefined, right? If init is equal to undefined, that is, if we haven't, if the user of this function, of this method, didn't supply a value for init, we want to do this, else do something else. What do we want to do? If it's not there, we want to set the result to array 0, and we also want to set I to 1. Otherwise we want to set the result to init and set I to 0. Okay, then we loop for, we already set I there, we want I to be less than array dot length I plus plus. So what we will be doing inside here, we're going to call the func, and it's expecting the accumulated value, which is the result, as well as the item and its index. Okay, so it's going to actually set the result, the new result, to that, right? At the end it will return the result. And that is all, my friend. Let me try to walk through it again. So we have our own reduce function here, which expects a func and an initial accumulated value, and then we are setting up our array, which is the array we are calling the reduce on, and it's pointed to, but this points to it. Now we are setting up the result and the counter. Then we check if init is equal to undefined. The reason we did this is because, let's say if we were checking for it being true, let's say if we were checking, for example, if we did something like this, right, we would have had a bug when we used it with 0 like this, was 0 is a false value. So init is double equal to undefined. Also works if, let's say, someone comes and puts null. So undefined and null, they are equal if it's double equal, but 0 and undefined, they are not double equal. Okay, and then we have if that's the case, it means we actually don't have init here. The result, this here, is going to be set to the first item, which would be this one, right? And I would be set to 1, meaning we would start counting from here. But if it's not the case, if we had our init supplied, and the result will start at init. Okay, so the result is actually the accumulated value. So after calling the callback function with a particular item, it will accumulate the value into a result. So now our result at the beginning is set to init, and I is set to 0, because we'll be starting from the index 0, and because our I is already defined outside in given value, we won't need to do something like I is 0 here, because then we are not expecting I to be always 0. It can be either 0 or 1, and we are looping over our array. And what we are doing is we call the func, right? We call the func with the result, right? At the beginning, the result is the initial value. For example, if we were using this example here, the initial value would be 0, right? And then what we are basically doing is we are putting, say, 0 here, okay, and then 1, that was the first value, right? So what we'll do is, let's say we used this function, right? We would say, would return this part here plus the current item, this part being the result plus the current item, and after we return it, we actually save it to result, which is this one we have defined up here. So when we are calling the func on the next item, let's say 2, right, the result would have been changed to 1 in this case, and it goes like that. It keeps on changing as we go. So here it will be 1 plus 2, and then 3. Here it will be 3 plus 3, and then to 6, and so forth and so forth until at the end. Of course, it depends with what kind of callback function we have given to it. Like here, we've given it a function, callback function, that actually adds stuff together, but it can be any type of callback function. For example, it can be a callback function that puts the items into a new array, maybe based on some kind of condition or something like that. Right, so we are done, and let's test it. Going to use our same sum, but now you change it to sum2, maybe sum2, and we'll reduce Ts and S instead of SCE, I mean. Then let's console log sum2. So we already console logged sum up there. Let's console log sum2, and then you see the results are exactly the same. You can use this reduce method wherever. You can use the built-in reduce. The reduce method can be used to achieve what filter, map, or for each can achieve, and more. That's why it's sometimes called the Swiss Army knife. And of course, our own version can do that too. Just an aside. Now, I also think this is the right time to mention that what we've been doing, recreating the built-in array methods and adding to the array prototype, is actually considered a bad practice. Precisely, the adding to the prototype of a built-in function constructor is considered a bad practice. We have been doing this only to clarify concepts at a deeper level and maybe inspire you to follow the pattern in your next cool library. That's all. Thank you guys for watching, and please don't forget to subscribe, leave a comment, and if you guys have any content you suggest I add to this channel, please let me know.